Greetings everyone. Today we're going to discuss the third question of the CodeChef. The name the crazy bishop on chessboard. Let's just read the question at once. Chef has a matrix of size n cross n, and there are n bishops placed in the matrix in a zigzag fashion at the cell. The cells are given. For example, n is equal to 4. The matrix may look like this. Your task is to determine the minimum number of moves required to reach position from each cell I comma I exactly one bishop for 1 to n. Okay, for n belonging to 1 to n. For the above mentioned case, n is equal to 4. The final position would like something like this, and it's given the rule how the bishop can move, and what's the input format. It will be t test cases. For each test case, we are given the n, and for that we have to print the answer. So it's a more or less observation based problem. Let me walk you to my solution and how I approached it. Okay, so let's just look at the cases from one by one. What would be the answer if the n is equal to 3? In the case of n is equal to 3, first we have to move this one to the end of the board, and so here's the one move, and then we have to move this to this. So for n is equal to 3, the answer will be 2, right? For n is equal to 3, the answer will be 2 for this n is equal to 3, right? For n is equal to 3, the answer will be 2. Now let's just look for the case of n is equal to 2, right? For case of n is equal to 2, what would be the answer? Both the elements are already in the diagonal one, so we don't have to do anything. Now let's just see the case for n is equal to 4. So for case of n is equal to 4, what we have to do? Similarly, we have to push it to the end, right? This one to the end, and then we have to push this one to here, the two moves, and in one move we have to push this one to here, right? So in total we require 3 moves. So we are observing a pattern, and that's the pattern is that let me that if any diagonal has 2 elements except the second diagonal or the second cell, if any element has 2 elements, for example, just see in this case, right? If it's having the 2 elements in a diagonal, right? So how many moves this 2 blocks will together contribute? These 2 blocks will together contribute, I guess, 3 moves, right? In first move, this will move to here and move somewhere down the line, and in second move, this will again move here, right? So each block will move contribute the third block, right? And for the first 3 cases, for example, n is equal to 1, n is equal to 2, and n is equal to 3. So answer will be, for those cases, the answer will already known. So what I have observed and how I have approached the question, that if my n is even, right? If my n is even, let me show you some. Let's see the for case n is equal to odd first, then we will take till for the n is equal to even. So for case of n is equal to 5, for n is equal to 5, we know if we subtract the n minus 3, then it will be what? It will be whatever the value it will be 2 here, right? For in and n is odd, my n is odd, so n minus 3 will definitely be even, right? So if it is even, then we know that the numbers or the cells will exist in pairs, right? Like see here, for n is equal to 5, if we subtract these 3 cells, if we know the answer for these 3 cells, then these 2 cells will always be in pair, and after that the cells will be there that those 2 also will be in the pair. So for any 2 pair, I have just observed like it will contribute 3. So my answer would be what? My answer would be the contribution of these till 3. So till 3 we know the answer, it's 1 move and it's 2 move. That 2 plus, we would subtract the 3 from the entire number of chessboards as bishops, as we know that we have already hard coded the answer for the 3 or till 3 cases we have already observed, and we have to see the number of pairs it will give you here, right? Because see, these two pairs will contribute 3, then again these two pairs will contribute 3, so we have to see the number of pairs, and in those number of pairs we have to multiply those pairs with 3. So this will be answer. And for cases n greater than 4, or n greater than equal to 4, what will be the answer? In those cases, the only one thing we have to add is that the one last element will remain in unpaired manner, right? 3, 4, let's see. See, here for these three we already know the answer. The answer is 2 only, right? And we know that if any bishop is alone, like if any bishop has don't have anyone in its diagonal, then definitely it will contribute 1 to its. And why it will contribute 1 to it? Because it will also move to the principal diagonal, and that would be the enough answer for it, right? We can do that thing. If you do the diagram, then you will observe that if we can only need to move this thing to here. And for rest of the cases we can observe in similar manner that we will move this here and then move somewhere here, 2 moves, and in 1 move this will come here. So 3 move in total for each pair, and 1 move for the those bishops which are not in pair. So answer will be what? Answer will be 2 for these 3 cases, plus 1. This one is for what? This one for this bishop which is alone and which is not in the pair with any other bishops. And for rest of the bishops, what we have to do? The n minus 4 by 2, the number of bishops pair, and each pair will contribute 3. So each bishops will contribute 3. So this will be the entire answer, right? It was more or less the observation based question. Yeah, I have already written here. For even, this is the formula, and for odd, this is the formula, and till n is equal to 3 we will hard code the answer. So let me give you the submitted code which I have used during the contest. So for n is equal to 1 and 2, I have hard coded the answer as 0. For n is equal to 3, I know the answer will be 2. And for cases n even and n greater than equal to 4, what I have done, the even cases, that the answer will be 3, and I have added the answer plus n by 4. The total, I have calculated here the total number of pairs, and each pair will contribute 3. So it is the answer for the even part. And for the odd part, the answer will be what? The answer will be, for first 3 cases the answer is 2, and then I have calculated the number of pairs into 3, and this is what the pairs will contribute, and I have take the summation of these two things, and the answer will be that will be my answer. So hope you understand the question. There is anything logical in this question. It was more or less the observation based question. So if you have observed, then it will be very easy, and rest might hit you hard. The thought process, or the approach to solve this question. Rest, it was the easy part. So this was all from my side. If you have any doubt or query, then please feel free to ask in the comment section and the chat groups. Thank you, and have a nice coding journey.